Hello all. It's a pleasure to be at Huddle, and it's more than a pleasure to actually share a stage with Professor Vijayaraghavan. So he's a stalwart in quantum computing and quantum technology as a academic veteran who has done years of work in research and have been developed India's first 6-qubit quantum computing processor. Please give a hands of applause to him for that. He has developed India's first quantum computer, and I'm so super glad to sit across him in this stage. And also a small backstory, like I was a student few years back. I was trying to get a project under him, and I sent 3 emails and no replies from me. You know how busy professor is. So super glad I will.
I've already apologized twice for that.
So super glad I'm sitting across him. So in that note, for people here, Professor would like to give, Vijay would like to give a brief introduction about quantum computing to start with. I think we can give a simple layman perspective about quantum computing. That'll be great.
Thanks a lot, Sreekuttan, for the introduction, and thanks to the organizers for inviting me here. I'm sure many of you have heard about this technology, and it always sounds confusing, and it is. In fact, whenever you try to explain it in simple terms, it looks like it's very confusing. But there are essentially two things you have to remember. It's a technology which relies on new rules. The rules which are used by our conventional computers, turns out, even though they are very powerful, and these days you can see all the great things happening with AI, it turns out that there are certain kinds of problems which the current type of computers can never handle. Though AI is really making a dent in that. And that's why you have to change the rules of the game. What I mean by that is that it's like you are going from a slow form of cricket, if you want to call that advancement, going from test cricket to one day to T20, you are making things faster, but the rules of the game are more or less the same. Similarly, as computers have evolved over the years, they have become faster. They do the same job in less amount of time because each step takes less time now because of this improvement in technology. But they are still using the same rules. So that restricts what they can and cannot do. So a quantum computer uses a completely different set of rules. And for that, we delve into the world of atoms, where the physics which governs them does not resemble the physics we see in our daily life. So if you consider an atom which we all think of like some small ball, it does not behave like a cricket ball in a stadium. It has very strange properties. You might have heard about things like how atoms can be in different places at different times. And this allows you to change the rules of the game. And the basic rule of the game is that the fundamental unit of information, which is the binary digit in the regular computers, you can have 0 or 1. In the quantum world, you can create an equivalent system which has new rules, and now you can have 0, you can have 1, but you can also have combinations of zeros and ones. And this is called a superposition state, and that is the main reason why you can do different things. So I think I will basically keep it at that this new possibility allows you to do completely different things, which makes you to solve certain kinds of problems which current day computers will never be able to handle.
So if you want to understand more about the theory, I mean, there is no best guy other than him. So quantum superposition, entanglement, there are so many first words. Please catch him to actually understand more about it afterwards. But as we talk about it's quantum computing. We are hearing about quantum computing a lot. But is it the only technology under quantum technology? Is it the only one, or do we have more?
Yeah, so that's a good question. Actually, this field is much broader than just developing a new kind of a computer. In fact, I will take a step back. Our laptops, our phones, they also work on quantum technology. They have this fundamental building block which is called a transistor, and the development of the transistor itself underlies quantum physics. But we distinguish that from what we are doing now. The old one is now called the first quantum revolution, which led to transistor, lasers, all of which have improved the technology we use every day today, to what is now called as the second quantum revolution, which uses this idea of superposition, the new rule I just mentioned. So apart from computation, there are several other aspects to it. One is communication. It turns out that the way we transact securely on the internet, or when we use our ATM or credit cards, it relies on a certain mathematical problem being very hard, which means that if somebody wants to steal your information, they have to solve a very complicated mathematical problem, which no computer in the world can solve. So it's secure. But it turns out that a quantum computer can actually break that. But there are new ways of doing communication, which again relies on some new rules which come from quantum mechanics. And this new rule is that in the quantum world, you cannot observe a system without disturbing it. So trying to detect anything fundamentally changes it. So this gives you some kind of a security in the sense that you can be sure that if you exchange some secret information, nobody has interfered with it. And that allows you to do quantum communication, which is a new form of security, which is guaranteed by the laws of physics and not by a particular mathematical problem being very hard. Another aspect is related to sensing technology. When you're trying to measure very small quantities, there are already very good quantum sensors which we actually use. The MRI in the hospitals, it relies on quantum sensing technology. What is happening now is that we are taking it to the next level, and again these new rules of the game allow you to make very sensitive detectors. So this can have security applications where you can maybe detect a submarine deep inside the waters using a sensor which is using these new rules of the game. So quantum sensing is another application. You can detect gravity in very, very sensitive ways, which can allow you to understand what is under the ground by just doing a sensing from the surface. And again, these are better, or they can be better now, because they are reliant on these new rules which quantum mechanics allows you. And then finally, there is a whole range of new materials which are being called quantum materials, which actually, I wouldn't say it's a fourth vertical, but it's a technology which feeds into all of these three areas, that is computing, communication, and sensing. So there's a lot of research, and that's why typically you hear about these four broad areas under quantum technology, which is quantum computing, quantum communication, quantum sensing, and quantum materials.
Can you guess like how many quantum startup which works on technology companies will be there in the whole world? Like Professor just mentioned about all these four key areas. How do you know, can you guess how many companies will be there? Just a random guess. Will it be about 1,000? There is actually 1,500. So there's actually 1,500 companies which works on all these key technology areas that Professor Vijay just mentioned. So it's quantum computing, sensing, metrology, hardware, and materials. And in quantum computer, so there are around 89. There is 90 startups, companies. So few of them are Google, you might know, IBM, you might know, you would have heard about IBM, Microsoft. Then there are a lot of startups that are actually trying to build. Then in software, so quantum software is like a layer which helps them. There are 30 plus quantum software startup. The most number of startups companies are in quantum materials and device, around 500 plus. So the ecosystem globally is so big. And in India, it's also growing. Professor will, of course, add about that. And the amount of money that government across the globe spending on quantum computing is really, really huge. They have spent around $40 billion. Government across the globe has spent around $40 billion, and Professor Vijay will be talking about India's initiative, of course, afterwards. So it is actually growing, and I think this is the right time to actually probably think about it as well. So in that note, Professor Vijay, can you talk about what India is trying to do to catch up with the world? Are we late? Are we super late? Are we just late? What do you think about that?
Yeah, I mean, we are late, but we are not so late that it's impossible to make an impact. So in that sense, a lot of the activity which is happening now is very crucial, and it's very welcome, because many of these technologies, the early inroads have been made globally, but the final sort of nail in the coffin, which sort of creates a practical technology, has still not happened. I'll just take a little step back, that I would say maybe around 10 years ago is when the modern quantum technology related research really started picking up in India. This was also around the time when I started my lab in TIFR Mumbai. And there were a few other labs, and these were now being done at the level of individual institutes, so who decided that we should get somebody in this field and get into this research. And then about maybe 5 years ago, the Department of Science and Technology started a program called Quantum Enabled Science and Technology Program. It was worth around 180 crores. And some 50 scientists from around the country covering these 4 broad areas were selected for funding. And that really sort of set the stage where now suddenly we had a lot of new labs, a lot of new infrastructure. And here I want to make a side point that one of the challenges here has been that any hardware related research in quantum technology is very capital intensive. So when I started 12 years ago, I needed $1 million just to set up a small academic lab. So similarly, any small lab working in any area of quantum technology, you can say that at the minimum from few $100,000 to up to $1 million to $2 million are needed to even just get started. So this obviously was not so easy back in the day when funding into science was not that high. But in the last 10 years, this has improved. And then the DST program 5 years ago expanded the number of such labs and the infrastructure and the quality of the infrastructure and the number of students and other technicians learning these techniques. So that then set the stage for the recently announced and approved National Quantum Mission, which some of you might have heard about, which is about 4,000 to 6,000 crores, which the government has planned to invest over the next about 6.5 years. And that is going to cover again these 4 broad areas. What has happened till now is that they have invited applications in January of this year, and then very recently in September they selected about 14 teams. So here each team is already a big collection of many scientists and engineers, and sometimes including companies and startups as partners, who will come together to to develop a particular technology, whether it's a quantum computing technology or a quantum communication technology. And the process for the final approval from the finance is going on, and we are expecting that the funds will start flowing sometime in January of this year. Next year, sorry.
So in that note, Professor Vijay talked about the academia and the National Quantum Mission. And I would like to add about the startups that are in India. So there are around 30 plus startups in India. They are in product development phase. Some of them are in commercialization phase. Some of them are actually generating revenue, especially the startups in quantum communications. Because quantum communications have been seeing good interest across the globe because of the security threat. They all fear the quantum computers are going to break the RSA encryption. So they are getting good revenue. They're generating revenue. So one of them is QNew Labs, and there are few other companies who try to develop quantum computing hardware, and mostly in communication. And so I think so as a founder, I should definitely tell about my company as well. So we are startup, quantum software startup. We build a platform which makes it super easier. Actually, we build the best platform which makes it super easier for anybody to start writing quantum algorithms. And we are a software player. We will try to bridge the gap between customers and the hardware Professor Vijay would be making. So that's essentially the startup system. There are 30. They are actually growing in count as well. So in that note, I would like to get to know more about the 6-qubit quantum computer that TIFR has built. So please, if you can.
Yeah, so this was a project which we started a few years ago. Unfortunately, it was exactly in sync with the pandemic, so things moved very slowly. But it involved collaboration between DRDO. So DRDO had started a new series of laboratories called Young Scientist Laboratories, the DRDO Young Scientist Laboratories, or DYSL, in many areas. And one of the areas they had chosen was quantum technologies. And for that, they had approached our lab to take up a project on building a full quantum computer. So given the level of development that had happened in our lab and in the country, and the kind of resources we had in terms of the access to the infrastructure for making these things, we decided to have a modest goal of around 6 to 7 qubits, which then eventually we settled to around 6 qubits. So these uses a type of technology which is called superconducting circuits. And maybe here is a good point to mention is that today, quantum computers can be built in several different ways. And in fact, it is not clear which of the methods will actually lead to the first successful, or when I say successfully, I mean a computer which can have economic or commercial value and can be used for practical purposes, at least commercially or in R&D. So people are trying all these different technologies, including in India also, the national mission will be supporting several of these technologies, because we don't know yet which one will win out, and it could be a combination of these technologies. So I work in an area which is called superconducting qubit-based quantum computers, and these work at very, very low temperatures. So something like minus 273 degrees centigrade. It is close to absolute zero. In the Kelvin scale, it's 0.01 Kelvin, if you want to think like that. And you really have to go down to such low temperatures, because temperature is like a noise, and you have to suppress all that noise to get this to work. So we started working on this around 3 years ago, and this thing is coming up. And we also have a third partner in Tata Consultancy Services, who are developing the software. And as Sreekuttan was saying, there are actually many layers to get the full computer working. Like your laptop or desktop also is not just a piece of hardware. It has the processor, it has the motherboard, it has the operating system, and then it has the application software on top of that. So similarly, a quantum computer has the quantum processor unit, which is the equivalent of the CPU. Then you have other electronics which you need to control that processor, and then you need the software to actually run the kind of quantum programs, and then ultimately some way to interface. So TCS came in to help us with developing the ability to host this on a cloud. So you can actually access this system from the cloud. So over the years, in collaboration with scientists from DRDO who came and worked in our lab, the project actually took place in our laboratory in Mumbai at the Tata Institute of Fundamental Research. And very recently, about 2 months ago, we had made an announcement that we had completed the full end-to-end testing, which means that we could go onto the web browser, submit a program, and then that program gets executed on the hardware, and then the results are posted back onto this web interface. And since then, we have been tweaking the performance, trying to get the performance improving, and then hopefully by March, we are planning to actually launch it, where everybody would be able to actually access and run their programs. So even like non-experts and also expert researchers will be provided access so that they can use it and also do further research on improving the device itself. So currently that's the stage. It's the first time a system like that has been built in India. So it was a proud moment for us, but we are waiting till March to formally release it.
Once again, congratulations for that absolute achievement. We are super proud. And our team would be really looking forward to get hands on that QPU, and really hope to actually work on that. So I'll also like to, it'd be great to also educate the audience here on what sort of projects are getting under National Quantum Mission, probably the project that you are got funded, what's the aspect and what's the prospects of that project?
Yeah, so I'll start by giving the broad overview of what the National Quantum Mission is hoping to achieve. It's going to cover all the 4 areas I talked about, and the support is not only to academics like us who are working in universities and institutions, but it's also going to support industry and startups as well. In fact, just last week, about 8 startups have been selected in a program which was part of the National Quantum Mission, and they have been selected for funding. So you have to, the first round has selected, apart from this startup one, they have selected 14 teams, which are developing various things like quantum computers. So even in quantum computing itself, there is the superconducting circuit, which I mentioned, but there is also semiconducting qubits, there is photonic qubits, and there is something called ion trap and atomic qubits. So similarly, there are several projects under communication, sensing, and materials. Altogether, about 14 projects have been selected. The project which I am heading is the one to build quantum computers using superconducting circuit technology. And in that, the broad main goals is to develop a 24-qubit quantum computer by March of 2028, so in about 3 years, and a 100-qubit quantum computer by March of 2030, so in about 5 years. To support this, there is also going to be a centralized fabrication facility, because the chips you need for making these quantum computers are really high-end and require a lot of sophisticated fabrication tools. Now, these tools do exist in various academic institutions, but they are not always the best, or you don't have all the tools in the same location. So we decided that we will need a comprehensive fabrication facility which will be eventually open to everybody who is interested in using that. So this will actually also apply to startups, that they can eventually be able to access those facilities if there is a startup on, say, a chip design, and they can get their chips made in that. So that will support the entire ecosystem and also the startup ecosystem, which is going to be very crucial. So apart from these broad goals, we also have smaller component development goals in it. I will talk about the project which I'm involved in, because as I mentioned, there are so many components for the full quantum computer. You have the quantum processor unit, but you also have a lot of electronics. You have cryogenics. All of these things currently are mostly imported. So at least we are going to try and make some of those available in India. We might still have to import the tools for some of them, but for example, there is a lot of cryogenic wiring which goes, connects the electronics which are operating at room temperature to the device at low temperature. So there is a special kind of wiring which is needed, and as you make larger and larger quantum computers, they have to be miniaturized and they have to be, operate at these kind of temperatures. So even the electronics itself, we are going to develop that, and we hope to interact with a lot of startups and industry to actually really push this forward and even take them into products, individual products, which can then have a global market as well. But I guess we will address that in a later question as well. So this is broadly what is happening, and similarly, all the other 14 projects also have their respective goals. The mission timeline is still March of 2031. That's the end date.
So, to conclude, I think I'd like to ask Professor Vijay, what are the commercialization aspect of quantum computing? Like, for example, let's say today an entrepreneur want to start their journey into a quantum computing business. What all avenues should they look at?
Yeah, so the first thing I would like to say here is that if you want to enter this game, you don't need to know quantum mechanics. Okay, so don't be afraid that the word quantum computing seems to think that you have to be a physicist who has studied quantum physics or understands quantum mechanics, because there are various aspects to this technology. In fact, people like me who are quantum physicists actually don't know enough about the other aspects which is needed to complete the full system, and which is why we are collaborating, we are forming teams with electronic engineers, with chip design engineers, software people as well, to build the complete system. My expertise lies in the low temperature quantum processor unit design and functioning. But we need a lot of people to come and bring in their other expertise. And in the last few years where activities have been increasing, what I've realized is that both Indian academia, government labs, and Indian industry and startups has a lot of knowledge and expertise already, but they just don't know that that expertise applies to these quantum technologies. So one of the things we will do is, once the national mission activity starts, we will organize events where we will engage with the industry and the startups to make them aware. I mean, this is an example of an event, and I will say a few things here as well. So, for example, electronics. All of the superconducting quantum computers rely on high frequency pulses. So they're kind of similar to how a cell phone works or a radar system works. So we already have so many companies which work on RF electronics and make these very high-end electronics. We just have to tailor them for applications for this particular quantum computer. So there is a lot of scope in developing electronics, and if you make a good product, it's not just that it's going to go into these 2 quantum computers which we are going to build as part of the Indian National Quantum Mission effort. It has a much broader, of course, global reach, because anybody who's developing superconducting quantum computers or similar ones, they can use that technology. So you have the opportunity to create a product which can have a global reach, and that's what many startups around the world are starting to do. Back in the day, we used to use off-the-shelf telecom products which were made for the telecom industry, and we would reprogram them and use them. But they were, general purpose things. Now you are making specialized instruments. Similarly, there is a lot of microwave signal processing related components. You have lots of microwave components like filters, specialized filters, and other signal processing things. So these are for like small component level. And again, if you can do a good job of developing a high quality product, the market is global. So what the national mission will do, and people like us who are executing these projects will do, is that we will create the infrastructure, we will do the prototypes, and then do a technology transfer to people who are interested. So the startups may also even come in at an early stage. And the game changer here is that you might be developing a $100 component, but it needs to operate at minus 273 degrees centigrade. To test it, you need $1 million machine, which a startup may not have. But the ecosystem now will allow, so like places like my lab and other labs will now allow the startups who are making these products to come and verify the performance in the infrastructure which we are creating. That's the plan. So that we don't have to set this up for every startup individually. They can then test it, and once it's verified in a well-established lab, then there is belief behind the success of that product. So that's really the opportunity. So it exists in electronics, it exists in microwave component design. Sreekuttan already mentioned software. There's a lot of software which we need to go from the high-level programming language to the language a quantum computer understands at the hardware level. There's a lot of software that is needed to actually tune the quantum computer so that it's working optimally. These things are right now done manually, like a student sits or a team of students sits for several days and tune everything manually. This can be automated. There are already internationally, there are companies which are developing software for doing that. So all of this is possible. And this doesn't require any knowledge of quantum physics or background. You just need to understand what is the application and what exactly needs to happen. And for that, people like us will engage with the broader community and help make this happen.
Yeah, thanks a lot, Professor Vijay, for all those insights. I think we'd be happy to take few questions. I think we have 5 more minutes to take questions from the audience.
Now the session is open for short Q&A.
Hello, my name is Pradeep. I'm from Pune. So it was a great session, Mr. It is a great session that you guys have just informed about quantum computing, okay? And really thankful about the inputs. And I just want to know about that how AI is going to be disturb this with the technologies. Like Sreekuttan has been his own founding company like Bloq Q, okay? So on the different technologies like Web3, then Metaverse. So and you just mentioned that the the new startups are coming and existing companies are working on that to building a small product or something kind of hardware instrument to be connect with the bigger solutions or problems. So how AI is going to be disturb these things, or how is it?
So there are actually mainly 2 possibilities. One is AI for quantum computing. Next is quantum computing for AI. So AI for quantum computing has multiple applications. If I remember correctly, there are for error correction. So Vijay can say that the current quantum computers are really error prone. So they have few really error prone. So we can use AI for error correction. Then AI for tuning and measurement, I think. So there are few areas where AI can help quantum computer. And the other way is also possible. Right now, we are trying to use quantum computers to build AI applications, like AI algorithms. We call it quantum machine learning algorithm. So that's a broader aspect. There are two ways.
Yeah, I'll just add to that the use of AI to further the quantum computing technology is just another tool in your box. Like as I was mentioning, you need software, but that software can now be AI powered, and that can help, and that is already happening. In fact, we have used AI techniques to improve certain aspects of the performance of the quantum computer itself. The other aspect, which is doing AI on a quantum computer, the main point there is the same. You now have new rules of the game. So that AI now can exploit those rules and give you something completely unmanageable that is. But for that to work, you need to have quantum computers reach a little bit more maturity that their error rates are small enough and they can give good performance before you can start trusting those results. So that will happen a little bit later, but that's definitely going to be a possibility in there. But I think a lot of scope for AI people to help push this technology further and faster to before it becomes practical.
Is government is supporting for that, for new startup with the AI things for the quantum computing here in Kerala? Is there any government program or something?
I'm not aware of a specific AI company which is working right now, but I know there is one AI company which has gotten into quantum computing. It's a company called QPi AI out of Bangalore. Okay. And in fact, they were one of the companies which was selected for this government funding last week. They are independently an AI company, but they are now starting to develop superconducting based quantum computer hardware. So I'm sure they may have some ideas to combine both those aspects, but I'm not aware of that just yet. But I mean, this is still early days. I think there's a lot of scope for new companies to come in.
Hello.
Sir, can you increase the mic, that mic volume? We're not able to hear here.
Yeah, please ask.
My question is, so compared to the traditional computer programming, right? So we have the bits like 0 and 1. So compared to that, how difficult or what are the challenges that you see, when you work with actually the softwares in the quantum computing field? So if you can actually mention a couple of the programming languages that you use.
Yeah, so that's a great question. Actually, depending on which layer you are programming, you don't need to again understand anything about the quantum. There's no difference. You can write a quantum algorithm in a Python script if you like. So what's going to happen is that at the highest level, you're going to have modules. These are particular modules which exploit these quantum algorithms to solve a particular problem. Now, because these are likely to be new problems, or these are solving the same problem in a faster and more efficient way, they give rise to many new possibilities for the kind of applications you can create. Just like AI is allowing new things, so new kinds of applications are coming. So that kind of programming would be done completely in any regular language, whatever the company is using. And these things will end up as just some modules, and you'll do some API calls to that, and you are completely unaware of what is happening. You just know, because remember that any application or quantum program, the input has to be provided in a language we understand, and the output has to come out in a language we understand. What is happening inside that box may not have, you don't have to understand it fully. You just need to know what it does. How it does it, it's not so important. But for much lower level where you are doing algorithm development, if you go to the lowest there it's not even writing a computer program. It's actually computer science, where you are trying to figure out how these new rules of the game are allowing you new possibilities. So some key ones have been discovered for several decades now. And that's the one where progress is slow, because it's very hard to figure this out. how the new rules of the game can help a particular problem. But once you go above that, once you know that a quantum computer is able to do X, Y, and Z, how to combine that X, Y, and Z for a particular application, that's just regular programming. So any things would work. So these days, these cloud-based quantum computers, they have some series of software, like IBM has their own software called Qiskit, which is open source. Similarly, Google and others have developed their own program. I think one of them is called Circ, and I think there is something else with some interesting name. But it really depends on which layer you're planning to work on.
Yeah, thank you for the answer.
I hope there are no further questions. Thank you, sir. We would
Thank
like
you.
to proceed you with a small token of appreciation. For that, I would like to welcome Ronnie K. Joy from Kerala Startup Mission. I would like to welcome Professor Vijayaraghavan for receiving the token of appreciation. I welcome Sreekuttan. Please stay back on the stage for a quick photo session.